today's. Again, a student will eat 3,300 calories a day. The chart below shows the food and calories a student will eat. The table provides a percentage of person each food types and food types the student eats each day. So first is garlic bread, 1 slice. Make this both again, and spaghetti plates. Make this into a decimal. So you get 0.2 and 0.8. Oh, you don't need to put the 0 at the end. But if you want to, it helps you understand better, perfectly fine with me. Times 100 times 100. Not 100 times the total calories here. 3,300. Oh my goodness. That's this to this, 2 times 100. And use your calculator. Point 2 times 33. Oops. 0.2 times 3,300 equals 132. Exactly. Equals to 132 calories. If it's 20%. And the other one, right there, you see. The other one is 0.8 times 3,300 equals to 2,640. Take that, divide by this, and you get 1 whole slice of garlic bread. And this is written wrong by that number, 660. You get 4 plates of spaghetti. So how much of each type of food does the student eat a day? The student eats 1 slice of garlic bread, okay, just you finish writing it, and 4 plates of spaghetti, okay, because the longer I videotape, the longer it takes to upload. If 3 students were eating the same food in a day, how many slices of garlic bread and how many plates of spaghetti is eaten? So there's 3, therefore you times this by 3. 1 times 3 is 3 slices, and times the plate by 3, you get 12. 3 slices of bread and 4 plates of spaghetti. Okay, and then you have this here. I'm going to have 2 outliers. Like that. Okay, so determine whether the scatter plot is a positive or negative association. Positive because if you write your name in here, it's going up. So it's positive association. Explain, because it's going up. List the coordinates of outliers. I chose to have 2. My first one is 9 and 70. 9 and 70. The second one is 5 and 100. Okay? All right, pick 2 points inside your piece of bread. Any points you like. You can make up one like I like right here. It's more in the center. You want to pick the center. So I think that's more in the center. I'm going to use that one. And then I'm going to pick this one. It's the center of my bread. So all of you can have different points. So my first point is at 4 and 60. My second one is at, 9.5 is not a good choice. Bad choice. So I'm going to choose 9 and right there. That's in the middle of it. 9 and 95. You can choose, or you can choose 7 and 80. That's a good one too. That's in the middle. Okay, we can choose the existing one. And then you draw in your line of best fit. Do not forget to draw in your line of best fit. Okay? Otherwise your points don't count if you don't have your line of best fit. 7 and 80. It's easier to choose your point, then draw your line of best fit, than do the other way around. Write a linear equation in slope-intercept form, okay? First, to write a linear equation, you have to have the slope. Okay, we're finding slope. Slope is y2 minus y1 over x2 minus x1. It's represented by the letter m. x1, y1, x2, y2. We've been doing so many of these. 80 minus 60 over 7 minus 4. You get 20 over 3. We'll leave it like that. Okay. Then you use y minus y1 equals to m parentheses x minus x1. Y minus y1, which is 60, equals to m, which is m is right here. It's the slope. M represents slope. Parentheses x minus 4. Okay. 20 over 3, by the way. Y minus 60 equals to 20 over 3x because we distribute. Distribute 80 over 3 plus a negative. 80 over 3 is 26.6 repeating. So 66666. So I'm going to round it 26.67. Okay. Add 60. Add 60. You get y equals to 20 over 3x. And then 60 subtract, because the signs are different, additive inverse. You get plus 33, that's a negative. Bigger numbers, 33.33, right? As an answer. Okay. In your equation, problem C, what is the y-intercept? This is the slope right here, guys. That's not the y-intercept. The y-intercept is this one here. The y-intercept is 33.33. Okay, make sure you know these things. Decide, evaluate, and explain the difference between the two problems. Okay, explaining for me, it's just showing your work. This is -4 times -4, which evaluate means to solve it. Positive 16, because 2 negative when you multiply is a positive. This one here means -1 times 4 times 4. Okay? Because there's no parentheses around it. So this is -1 times 16, which is -16. This is explaining if you know that. All right. Exploring products and powers. Rewrite each expression by using powers of product. Record the number of times a base is used as a factor. Okay, now we need to do this direction as it says because you need to see what's happening. Okay? Rewrite it as a product. So that's 2 times 2 times 2 times 2. The other one right here, 2 to the third power, is 2 times 2 times 2. So our answer is 2 to the 7th power. Record the number time a base is used as a factor. So they didn't say to solve it. They want this as an answer. So you can see, if you haven't seen yet, to get our answer, all you have to do when the base are the same, that means these two are your base, are the same. All you have to do is add that. You get this 7. Okay, they want you to start noticing that. So this, when you add this, your answer should be -3 to the 5th power. Okay, because you get here, there's the reason why is there's 3 negatives here. They want you to understand this, so they want you to write it out. If you should forget, you just write what it means and you'll get the same answer too. The second one is -3 times -3. You get -3 to the 5th power because there's 1, 2, 3, 4, 5. Or you can just simply add the exponents. Easy as that. Okay, so this, again, if there's no exponent, there's the 1 right there. Okay, so basically 1 plus 6 is 7, so a to the 7th. This one has 1a. Okay, the second one has 6 a's. That one has 6, so a. Because it's a positive variable, so altogether you have 7 a's, so a to the 7th. Or you just add the 2, a to the 7th power. That's your answer. Okay, this one here, you add those two together. There's m, 2m there. Use commutative property. And then 3 m's here. You get m to the 5th. And then you look at the p's. P here is p to the 2nd. So you get 2 p's. And here you just only have 1 p. So you get p to the 3rd. Or you can just add them, you see? 2 plus 1 is 3. And here there's the m's. If you do the m here, that's 2 plus this 3 is this 5 right here. Okay, so it's 5 right there. Just this concept you need to understand, the reason why we add the exponents. Okay, and the same thing. The ones with the same base are the 9 and here. Basically you have 9, 9, 9. Multiplication in between. And the other one, you get 9, 9. You got 9 to the 5th. Well, understand 3 plus 2 is 5 also. Make sure this is written too big. I need to write it smaller. Y to the 7th, because 2 plus here. Also the concept, you need to write it out because that's what they want you to understand. There's 2 there. And there's 5 here, making it 7. Okay, that's your answer. All right, this one too. You cannot add these two together at all. Those two cannot be added. So it's 2 to the 3rd times 4 to the 2nd. cannot add the exponent because these bases of 2 and 4 are different. The only time we can add them together, as you can see, are when the bases are the same and we write out the same amount, then we add them together. This one, you cannot do that because here it's 2 times 2 times 2, and here is 4 times 4. They're not the same. You can't say 2 to the 5th, there's no 2 5s. Can't say 4, so they are different. So you say 2 to the 3rd, 4 to the 2nd. You can't add them together at all in any way. Now the F's you can, because look, if you write it F 5 times, 1, 2, 3, 4, 5, and then 3 more F's right here. 1, 2, 3, they're all F's. They're the same. When the base are the same, you can add the exponents together. So you get F to the 8th. 1, 2, 3, 4, 5, 6, 7, 8, right? And that's your answer. What rule can you use when you're multiplying powers? Add the exponents when the bases are the same. Same only. Okay. So for example, like these two right here, M and P, the bases are not the same. You can't add them, right? You can't add 5 and 3. Okay. So this one here, simplify means to evaluate them. Okay, so let's see if we can evaluate. Here, you can evaluate the 4 to the 1st, 3 to the 1. You can evaluate that to get 12. Okay, now the K, we will use the rules. It says we can use the rules here. The rules you wrote, which is adding the base. Okay, we can use that, and that. We write it like this. K, how I want you to show work with the 3 exponent plus the 2 exponents plus this 5 exponents right here. So we get K to the 10th. Okay. Same here, we can have the 5 and the 2. 5 times the 2, they're not the same base, we cannot add them, but we can multiply 5 times 2 to get 10. This is h to the 1st right here, with h to the 1, plus h to this 10, plus the 10, h to the 6, plus the 6, and h to the 17. Okay, right here. Hey, look, these bases are the same. We can write 3 9 times and 3 1 time to get 3 to the 10th. We can add, so 9 plus this 1 here. Okay, it makes sense. And then here's the y to the 2nd and to the 5th. So we got y to this 2 plus this 5. Get 3 to the 10th and y to the 7th. That's our answer. Okay, and then this right here, hey, this base are the same. 4 and 4. So we have the 2 and the 12. 4 to the 2 plus that 12. And then y to the 20th plus the 10. Okay, so y to the 4 to the 14. And y to the 30th. That's our answer. And why is it possible to add the exponent? Why is it possible to add these two together to get 4 to the 14th and not these? Right here, bases are the same. And here, the base are different. Okay? So with 4 squared times 4 to the 6th 12, the bases are the same. With 5 to the 1st and 2 to the 1st, the bases are different. All right? So let's simplify this. We got n to the 20th, and then n to the 2nd. So we plus the 2, right? Commutative property of multiplication, we can do this. P to the 8 and p to the 2nd. So we get p to the 8th, we'll add that to the 2, n to the 22, and p to the 10. This one here, that's a 1, invisible 1 when there isn't any. Okay, so that gives you 7 and the 7 have the same base. We can add the exponent. So 7 to the 3rd plus the 1. This is how I want you to show work, okay? Don't just give me answers only. W to the 4th plus this 1. So 7 to the 4th and W to the 5th. Okay, these two are not the same base. You cannot add their exponents. 2 times 10, they're not the same base. That's only 20. You can multiply them though. Okay. And then d to the 1st right here. Put it a different color. And then d to the 4th here and d to the 15th. Base are the same. There's 1d here, 4d here, and 15d here. You add them all up because the base are the same. You get d to the 20th. That's your answer. Okay, the review part. Solve each system by graphing. Then state no solution, one solution, or infinite solution. Explain. Okay, graph these. We know these are going to be one solution because notice the slope, that means they're going to cross, are different. Okay, one solution. We need to find where is it at because slopes different. Okay, for sure. Let's graph it though. It says for us to graph. We start at the y-intercept 4. Y-intercept at 4. Go up 1, right 2. Up 1, right 2. Then go the other way to keep the lines nice and straight. Okay? There we go. This one, the y-intercept is at 2. You go down 1, right 2.